Yeah. So, um, good afternoon, everyone. Welcome to our lecture today. I hope you can all hear me.
Yeah, sure.
Okay, that's fine. Okay, so what we'll be doing today is that we'll be going through program development and we'll walk through how to write up our algorithms, and then we'll look at some tools. Two of the most important tools we will look at are pseudocode and flowchart. We'll look at how those tools can be useful or are practically used when we are designing algorithms. Okay. Okay. Now, if you remember or recall, I did say when we met in class or in person the last time that an algorithm is basically step by step or a step-by-step approach to solving a problem. Okay. And one important thing I did mention from our discussion the last time was that the algorithm has to be unambiguous. Okay. So when we say something is unambiguous, we simply mean that the particular sentence or particular statement has exactly one interpretation. Okay. Or the interpretation is widely understood. Okay. So what we mean by algorithm being unambiguous is that the algorithm has to be written or has to be represented so that everybody who is reading the algorithms or following the algorithm can produce the same result. Are you with me? Okay. So basically, and when we say the algorithm is a step-by-step approach, we are comparing it to something or somewhat like a recipe book. Okay. So remember when you want to cook food and maybe you don't know how to cook the food, you consult a recipe book which describes or discusses how you can step by step cook the particular meal. That is what an algorithm basically describes. An algorithm shows you how to produce or get the same results that the person who wrote the algorithm got. Okay. So in some instance, you have maybe a problem, and then what happens is that after thinking through the design of the solution to the problem, you generate an algorithm which can be translated into a program. Okay. Then your programs need some information or data. So the program is fed into the computer plus the information, which gives you eventually some output that you require. Okay, so please have this at the back of your mind. Algorithms are very important, and their key purpose is that they carry or they look or they have the idea that will generate the solution that we require. Okay. Now, what are some examples of algorithms that we see in our day-to-day, okay, or in our carrying out our computer duties? Now, notice that most of us do search all the time, right? If you remember, you are always searching online, searching on Google, searching through files. When if it's a tall list of items you want to look into, you are looking through them. Okay, so this is being done because some people have sat down to describe to the computer how to accomplish the search. So search can be done either as a sequential or linear search, or search can be done as a binary search. These are two ways that computers normally do search. Okay, and this is described by an algorithm. We can also sometimes use graphs. Graphs, more typically, those of us who use Google Maps, okay, if you use Google Maps or you use any of the mapping tools, you realize that mapping, you realize that mapping or using Google Maps when you want to search for a particular location, okay, you want to maybe search for from Kumasi to maybe Pukwase, or from Kumasi to maybe Achimota. Notice that Google Maps looks through a maze of cities or points on a map to try and generate the correct destination or the correct directions from from Kumasi to Achimota. We describe that as a graph, okay, because we have points on a map, and then these points on a map are looking like they are a graph, okay? And then what the graph algorithms try to do is to show you how to move from one place to another place, okay? And then get to your desired destination. We use algorithms like Distress algorithms, Kushkal's algorithm, Prince algorithms, something called depth-first search or breadth-first search to traverse or go through the members of a graph or a tree. And we have so many of these things. These are all examples of algorithms that are used by people who use computers, okay? Most of you interact with Facebook, or maybe you go on TikTok, you have friends on Instagram. All of those things are social media networks, and in fact, the underlying infrastructure for looking at any of those things is called graphs. Okay. Now, we also sort information, especially when we search for something. So, for example, if you ask Google to search for something, when the results are being presented, Google has a way in which it sorts the information. Okay, so we have bubble sort, we have insertion sort, we have merge sort, we have quick sort, we have heap sort, we have so many sorting algorithms. All of these are good for different situations or different scenarios, okay? And they describe to us how to let the computer do certain things, okay? These are all types of algorithms or kinds of algorithms. Now, what do we, or how do we describe or say that an algorithm is good, or algorithm is sound? Now, for an algorithm to be good, the first and most important criteria that I think by now you might have gotten is that the algorithm has to be unambiguous. When we say something is unambiguous, what we simply mean is that everybody understands it without any further simplification, or we understand it without several need to explain the algorithm to everybody. Okay, so when I say maybe create a variable or create an integer variable, it is as simple as that. Everybody understands that in order to create an integer variable, we declare the int, and then maybe we create a variable name, and then we end that line of code. Okay, so an algorithm has to be simple enough for everyone to understand. Another key characteristic of algorithm or good algorithm is what we term as what? Well ordered. When we say an algorithm is well ordered, what we simply mean is that the algorithm is written out systematically in a clear and orderly way. Okay, what we simply try to understand also over there is that, for example, if there's a particular line which needs to be on line maybe 1, it does not appear on line 10. Whereas the line, maybe the line on maybe line 10 will appear now on line 1. Okay, so when that happens, then the algorithm is not in a clearly written order. Okay, it needs to be written so that the algorithm is in a clear and orderly fashion or orderly way. Okay. Another key feature of a good algorithm is that the algorithm is written to be correct. When we say an algorithm is correct, we simply mean is that the algorithm produces the expected output for any particular given input. So, for example, if we expect that our algorithm will give us the square of a number, okay, so we've written a program and give us the square of a number. We don't want to give the maybe for 2, we expect that for 2, the square of 2 will produce what? 4. And then suddenly, hello?
Hello?
Is there a question? Hello?
Yes, sir.
Kindly continue, sir.
Okay. Okay. So then we don't expect that when the algorithm is maybe supposed to give us 4, then after entering 2, maybe we, instead of getting 4, we get something like maybe 4.8 or 4.2 or something. You see, that is not the answer we are expecting to get. Okay, so if we don't get expected answers, then we cannot say that the algorithm is correct. An algorithm that satisfies the correctness principle indicates that that algorithm produces the expected output. Okay, then also an algorithm, one of the key features is that an algorithm has to be efficient. What it means is that the algorithm must use reasonable time and utilize minimum number of resources. So maybe you wrote an algorithm, but your algorithm takes 50 years before it generates the expected results. You see, notice that we can say that your algorithm produces the results, but if we are expecting the answer today, but we have to wait for 50 years for your algorithm to run and produce the results, it means your algorithm is not very efficient. And also, if we have an algorithm where the algorithm is not utilizing memory efficiently, for example, the algorithm is running such that it is consuming all the memory resources, or it is clogging up, or is doing.
Hello, sir.
Can you hear me, please?
Yes, we can hear you now.
Okay. Okay, sorry. So I'm going to go back. Okay. Okay. So, or the algorithm is clogging up all the memory or using up all the information, all the memory on the device, then we cannot say that that a particular algorithm is what? Efficient, like we are talking about. Okay. Another key feature of a good algorithm is that the algorithm needs to be written so that we can go back and maintain it. Notice that your WhatsApp or your Facebook that you've been using, after a while or periodically, you get updates, right? Most of you get updates and then you update your app. You are able to update your app because the program has been written to be maintainable. You can go back and then make corrections to the program code, maintain it, or change or modify it, any part of the code, or even correct or debug pieces of the code that you are looking at. Okay, so when we write the code that way, then we describe, or when the algorithm is written so that the algorithm can be reworked, or we can rework or go back and modify the algorithm, we call that, or we refer to that feature as what? Maintainability or maintainable code. Okay, then sometimes too, one other key feature is that the algorithm has to be scalable. What it means is that we should be able to increase the number of users, or increase the amount of resources, or reduce the amount of resources depending on what the algorithm is doing. So as the system grows, we should be able to handle more inputs without a degradation in performance of the algorithm. Okay, so when an algorithm satisfies some or all of these, we describe the algorithm as what? A good algorithm. It has to be unambiguous, that is very simple to use or simple to understand. It has to be what? Well ordered. It has to be correct. it has to be efficient, it has to be maintainable, and then it has to be scalable to satisfy these conditions. Okay. Now, what are some of the types of algorithms we can find in our IT or in IT? Number one, you can find something called brute force algorithms. So brute force algorithms are a type or a way of writing algorithms where we write them so that they go through all sets of possibilities. Okay, so for example, if we have to find, if I give you my phone and my phone uses a 4-pin number, okay, and I ask you to log in or get into my phone without the password or without the pin, what you may try to do is that you may try to enter all the possible numbers on the phone to try and see if 4 of those combinations will unlock the phone. That is an example of using what we call brute force, okay? Using not necessarily, how do you call that? Not necessarily intelligence of any kind, but just using sheer force to try and generate all the possibilities, okay? So there are some algorithms that just use sheer force or sheer grit to try and generate the possibilities. Then we can also have what we call recursive algorithms. Recursive algorithms are algorithms where we try to solve a problem by breaking the problem down into smaller units. So for example, if I ask you to find the factorial of what? Of 5, okay? Because we don't know the factorial of 5, what we may try to do is to reduce the number and find the factorial of what? Of 4. Because we don't know the factorial of 4, what we do is perhaps maybe reduce the number factorial of what? 3. Because we don't know the factorial of 3, we'll go ahead and then reduce the number and then go ahead and find the factorial of 2, which is what? 1, and reduce the number further and find the factorial of what? 0. So 1 and then 0 factorial. But we know the factorial of what? Of 0, which is what? 1. Okay, so we go ahead and then multiply. We go ahead and multiply the answer together. Okay, so 5, 4, 3, 2, 1. Okay, so we go ahead and multiply the answer together. We multiply the answer together. We multiply the answer together, and then we keep on summing up. And then at the end of the day, we present the answer for the factorial of 5. Okay, this idea or this way of doing things is what we call recursion. Okay, it's a very nice way we can work things out in programming. Okay, I hope you are following me, please.
Yes, please, sir.
Yes, sir.
Okay, then we can also have what we call divide and conquer. Divide and conquer, the idea is that instead of solving the whole thing together, which we cannot solve because it's very big and it's very complicated and large, we divide the thing into half. Okay, so divide it into half. Then go and see if you can solve the half, which is there. If you can't solve that half, divide that half into half. Then divide that half into half. Then keep dividing until you reach a point where you can solve the small portion. Okay. Now, when you solve the small portion, it means you have solved part of the entire problem. Now, keep solving small portions like that and combining until you solve the entire region or the entire problem together. Okay. We call that divide and conquer. We divide the problem into smaller sub-problems. A typical example is, for example, if I give you a lot of numbers and I ask you to sort those numbers, you will not be able to sort those numbers. But if you keep dividing the numbers into small pieces until we get 1, 1, 1, 1, 1, 1, you can easily recombine the numbers bit by bit and sort them together. We call it, an example is the merge sort and the quick sort. Okay. Then another way we can solve problems in programming is called greedy algorithms. So greedy algorithms is algorithms or a way to solve problems where we look for the local optimal. Okay, we look for the local optimal to solve the problem, hoping that once we solve the problem with the local optimal, it can lead to what? The global solution. So a typical example is graphs, where you are solving a problem where maybe you've plotted the graph, okay, and you've realized that one of the solutions to the problem is the point on the graph over here. So you know the X and Y coordinates. But remember, this is only one of the solutions. This is not the entire solution, okay? This is only one of the solutions. To solve the entire graph problem, you need to find all the derivatives of that problem, okay? And maybe one of those other derivatives of the problem will be what greedy algorithm does is that because we found the first one, we stop at the first one. Okay, we call it greedy algorithm. Finds for a local optimal solution. Okay. And sorting problem or sorting algorithms. So sorting algorithms, what we normally do is that here we are simply trying to sort a set of items. And we can do it in many different ways. We can do it easily by arranging them, or easily by picking the items and putting them in the correct order, or doing some form of arrangement ordering. Okay. Then I talked about searching. So here we have linear search and binary search, two of the most important searching algorithms in programming. Then we can also have graph algorithms. So graph algorithms referring to algorithms where the data structure we are looking at is a graph, and we want to go through the nodes in the graph. Then we have dynamic programming problems where the problems are not linear, but what we want to do is that if we have already solved a particular problem and we know the answer, we don't go back and resolve the problems when we are faced with another problem, but instead we return the answer that we have memorized. Okay, we call that dynamic programming algorithms. At this point, I want to ask if there are any questions you want us to address. Any questions? Hello? Okay. So how or what are the methods for writing algorithms? If I want to write an algorithm, how do I go about writing an algorithm? Number one, we have to first define the problem. It is important that you, the developer or the programmer responsible for the programming, you understand completely the problem that you are solving. You recall the specifications of the problem you are solving. You can define what the inputs are, what the processing is, and what the outputs are at minimum. You should be able to know what those things are. Then once you've done that, number two, you go ahead and list all the inputs. So the inputs are the information you need when you are trying to solve the problem. Okay. Then you describe the processing, the steps that you take to convert or change the input to the output. We call that the processing. So we do the inputs, the processing, and not forgetting the output. Okay, so these three things are important. If you remember, we have talked about this in the framework. Okay, the inputs, the processing, and the outputs. So when you have any problem, you need to first understand the problem. Then you go ahead and list all the inputs to the problem. Then define the processing. Then go ahead and print the answer. Then when you are done, you check whether the answer has solved the problem or has not been able to solve the problem. Okay. So one of the tools we will use in solving programming problems is pseudocode. Okay. Now, pseudocode is a form of informal language independent. By language, we mean programming language independent, okay? Way of representing an algorithm or the logic of a computer program. So if you want to write the logic of a computer program in English, we normally would write it using pseudocode or write it in pseudocode. Now, pseudocode uses step-by-step outline statements. Pseudocode also uses short, semi-formal English-like phrases. When we say English-like phrases, what we mean is that don't go and write an essay. We are not writing any essay in pseudocode. Instead, we are writing short statements. An example of a short statement is start or begin. Or we can write declare. Or we can write write. Or we can write input. Or we can use the word end, stop. These kinds of words are what we use in pseudocode. They are short. They are English-like statements. They tell you exactly what we want to do without having to write a whole paragraph. Pseudocode, we don't write a paragraph in pseudocode. Are we okay? So sometimes the pseudocode strongly resembles actual code. It's important to remember that. Sometimes you write pseudocode, and if you understand maybe a particular programming language, you can easily look at that code and see the resemblance of that programming language in that code. Are you okay?
Yes, sir.
Okay, thank you very much. So let's look at pseudocode. Now, what are some of the uses? Number one, pseudocode can be used for describing how an algorithm should work. Okay, that's one of the uses. Number two, pseudocode can illustrate a particular construct, like an if statement, like a while statement, like a do while statement, okay? Like a for loop statement, like a for each statement, and so on and so forth, okay? Pseudocode can be used to illustrate, to show us how those things should work, okay? Pseudocode too can be used to explain the computer processing, okay? It's very important for that purpose. It helps us to also explain how the computer is carrying out its various operations, okay? Then pseudocode can be used to design code in collaboration with other people, okay? If you are working in a group, we might first want to meet and write our group project or the understanding in pseudocode before we each go and sit and rewrite our program in actual code, okay? So now, what are some of the tips I can give you? In fact, there is no right or wrong way for writing pseudocode. So let me stress, there is no right or wrong way, but you have to be just consistent. You, the programmer, you have to be consistent. What do I mean by consistent? You have to maintain a certain consistency. For example, you can't begin your pseudocode with start in one instance, and then another instance you begin with begin, okay? So try as much as possible to use or to stick to a particular standard so that people don't misinterpret what you mean, okay? Number one over here, always capitalize the initial word, okay? It's important to make sure that people can identify what the starting word is. Number two, make only one sentence per line. In pseudocode, we don't write English grammar paragraphs, okay? We just write one sentence per line, and the sentence has to be code-like, okay? That it cannot be pure English-like statements, which when you read, you can clearly see that the person is writing an essay. No, you cannot write that in pseudocode, okay? So we advise that you rather use one sentence or one statement per line. Number two, we want you to indent your code to show hierarchy. So, for example, it's going to take a while. Okay, let me just use that. So, for example, if we have an if statement, okay, and we are checking something. If we have an if statement and we are checking something, excuse me, please. Okay, sorry about that. I had somebody come in my office. Okay, so let's go back. So, like I was saying, capitalize each word, make one statement per line, indent where possible. Okay, and then number 4, always end multi-line sections using any of the end keywords. So we'll see that very soon. Then number 5, keep your statements programming language independent. What we mean is that because you don't know any programming language yet, don't try and write C++, or try and write C, or try and write Java, or try and write any. Just write what you know, which is English. Okay, so just write it in English, but write it in short statements or phrases. Okay, so that everybody can understand and you yourself can read and understand what you mean. Okay, then what we also want to use is that use the naming domain of the problem. So, for example, if we have to do simple interest, okay, everybody knows that simple interest, we have what? Principal times time times rate, all over 100. Okay, so when you are naming your variables, just imagine somebody will name their variables Y and go and name Z and go and name T, P, or M, and go and name maybe U over 100. How will somebody understand Y is equal to Z times M times U over 100? But if you use P times T times R, everybody who's reading this will understand that P stands for principal, T stands for time, and R stands for rate. Okay, it's easier for people to understand this one than to understand the second one. Okay, so please remember to use naming from the problem domain and not the implementation. And then, like we always say, keep it simple. Don't complicate things. Okay, keep it very simple. Don't complicate anything. Okay, so now let's see some examples of pseudocode that can have. Okay. Oh, sorry. So here we have, in the first example, we have a program. We have a program that is adding 2 numbers. Okay. So how do we add 2 numbers? Let's think about it. For our input, we need 2 variables, maybe let's say X and Y. Then for our processing, okay, we need the sum is equal to what? X plus Y. Then for our output, we need to print what? The variable sum, because that's the one that contains our sum. Okay, so having understood the idea, now let's go and look at how the pseudocode can be written. So we see that for the beginning, our pseudocode begins with the first line, begin. Like I said earlier, in your programming, you are allowed to use any synonym, okay? Because this is pseudocode, there's no right or wrong, okay? So you can say start, you can say begin, you can say first, okay? You can use any word which is a synonym, okay? But make sure you don't write a whole sentence, or make sure you don't write a whole paragraph. This is the beginning of the sentence or the beginning of the program. The program would no, we don't want any of that, because in programming we cannot have statements that can do any of those things. Okay, then you can see that on the second line we declare the 3 variables. So we needed 3 variables, x, y, and sum. Okay, here we're calling the variable num1, num2, and then sum. Then we create, I told you about this thing, we call it a prompt. Okay, when you want to take something from the user, you create a prompt. So a prompt is a statement that cautions or tells the user you want to take something from them. So usually it's a print statement. Okay, then we take what we want to take from the user. Okay, then we do another prompt again, enter second number. Then we take what we want to take from the user. Then when we are done, we are now done with the inputs, okay? So we need to go ahead and come and do the calculation, which is what? The processing. So notice that over here, for the processing, I use set to tell you that I'm beginning the processing, okay? And what am I doing? I'm setting sum equal to num1, which we've already collected, plus num2, which we have collected also already. And we put the answer where? Inside sum. Now we want to print the answer to the screen. And so we say write, then we do quote answer colon quote plus sum. What it means is that the user will see answer colon maybe 2 or maybe 4 or maybe 5, provided we give the numbers over here. So for example, if I enter the numbers 2 and I enter this number as 4, then the answer will be what? Will be 6. Are we okay? Any questions about that one? Sorry about writing so much on it. Hello? Any questions?
Hello, sir.
Yes, sir.
Hello. Yeah,
I
so
can
for
hear
the
you.
for the display of the answer, yeah, can you hear me?
Yes.
So I was saying that for the display of the answer, can you use display answer and then the num2?
Oh, yes. Like I said, you can use any of the synonyms. Okay, so you can do display, you can do print, you can do show, and so on and so forth. Okay? Are you okay?
Yes, please.
Okay. Any other? Okay, so whilst you are thinking about, or other people are thinking about the questions they want to ask, let me check the chat and see. Okay. Okay, there's no question in the chat as well. So let's go back to our screen share. Now, here we want to calculate the area of a rectangle. Okay. Now, what is the inputs? What's the inputs? We need what? For rectangle, those of you who have forgotten what a rectangle looks like, we have the length and we have the width. So we need a variable for length and a variable for width. Okay. Then what is the process? After collecting the length and the width, what do you do with it? You calculate the area. Okay. It's equal to what? The length times the length times the width. Okay. Then what's the output? The output is what? Printing the area. So now let's begin. So we start the program. We create the variables. Remember, we need a variable called length. We need a container for width. We also need a container for area. So we create 3 important things: length, width, and area. Remember, all 3 of them are integers. Okay, so please take note of that. You could have made them float or double or whatever it is. So remember that when you are creating, you, the programmer, are in charge of assigning the data types. Okay. Then what do? You now do your prompts. So see your prompts over here. Remember, you are only allowed to enter two important things, the length and the width. So you need a prompt and then the input. The prompt and complete. So want to put from someone, okay, from a user. So remember to put a prompt, a print statement that tells the user that you want to take something from them before you take the thing from them. Are you with me? It's important that you understand this. So notice that over here as well, same understanding came in. Prompt, input, prompt, input. Please remember that always, okay? Then the processing, where area is equal to length times width. Then afterwards, you have your answer as area. And so you can simply put that answer inside the variable called area. Any questions so far?
So
Yes.
yeah, I wanted to ask the number 8, right? Area. Why do you put plus before the
Okay, this
area?
one I've already mentioned. It is called concatenation. For example, if I have a string, maybe I have pen, okay, and I have another string is, and I have another string a boy, okay. If I want to combine all three of these strings together, I'll put a plus in between them. So in the end, you see Ben is a boy. When you see the plus, it means we are putting or we are attaching this to the back of the string. Okay. We can only use the plus for calculation like 2 plus 2 or 3 plus 3. But in programming, we can also use it to pick something, okay, and put it at the back of another thing. Okay, we call it append. Okay. When you do that, we call it append. Yes, any question? Hello, are you there?
Yes, sir.
Yes, sir.
Are you okay with the answer? No questions?
Yes, sir, we're okay now.
Okay. Another example. So in this example, we want to find the average of 4 numbers. Same idea as well. You go and now look what the inputs are, become what your variables. Okay? So please remember, the input become your variable. The input, what you need user to solve the problem. You want to find the average of 4 numbers. What do you need? You need the 4 numbers. Okay, so it's important. Then you want to add the 4 numbers and then find the average. In fact, that's a plan. So the inputs are the 4 numbers. Then you want to add the 4 numbers. So you create a variable called sum. Okay, that's why this variable is here. Then you want to divide by the total number of numbers, which is what, 4. And so the variable is also going, the value is also going to go into the variable called average. Are we okay? So here you create the 3 variables. So remember to write declare int num1, num2, num3, num4. Then we declare int 2 variables, the sum and the average. In fact, I could have added it to the back of this one, but I didn't want the whole thing to be very long. Okay, so you can add it to the back if they are the same variable. Please remember, if they are the same variable, add them to the back. Okay, now line 3 is asking us to is telling the user to enter all 4 numbers at the same time. So you see the first number, comma, second number, comma, third number, comma, and then lastly the last number. So this is how to also specify when the variables are the same and you are collecting all the inputs together at once. Okay, then we add all the 4 numbers, we put the answer inside sum, and then we divide sum by 4 to get average. To get the average value. Okay, then we print the answer results colon quote plus AVG. Okay, any questions?
Yes, sir.
Okay, let me hear you.
So, for the average of the number, let's say, or is it that the program specify only 4 numbers? Because I was expecting if the user entered, let's say, 5 numbers, how are you going to check for that?
Then you just create another variable.
Oh, okay.
Yeah. But for now, our program says 4 numbers. That's why we have 4 variables or 4 containers. Okay.
Okay.
I'm not sure if we ask you to find 4 numbers, you will say that because you can find 5 numbers, so you are doing 5 numbers. You do what the question is asking you to do. You get it?
Yes, please.
Okay, thank you. You get it. Yes, any other question, my dear friends?
Oh, sir.
You are good.
Okay, so we then follow up with a last example over here. So in this last example, we are finding 2 important things, the area and the circumference of a circle. Now listen carefully. So for processing, we know that area is equal to what? Pi r squared, whilst circumference is equal to what? 2 pi r. But remember, in the computer, we can't write pi, okay? You can't type pi on the computer keyboard, okay? So we'll have to find a way to represent pi. And what we are going to do is that we are going to write pi for pi, okay? So please remember, when you see pi, it represents this pi thing we have over here, okay? Okay, so let's proceed. So in order to find the area and the circumference, 2 important things we need over here is the radius. Okay, so we need the radius. Don't forget that we also need to tell the computer what pi is. So 22/7, okay? And so once we collect these 2 things, we can calculate the area and the circumference. We can calculate the area and circumference for pi, and then the output will be what? The area and the circumference. Okay, so please follow along. So first and foremost, like all what we do in every program, you have to create your variables. So we create all the variables. We have a variable for radius, variable for area, variable for pi, variable for what? Circumference. Then we collect the inputs. So remember, input is done after creating the variables, okay? So the only input we need for the circle is the radius, okay? Here, we now go ahead and do the calculations. In order to do a calculation, we need to put 22/7 into pi before we can use it for calculation. Then put that value of pi into the formula to get the difference. Okay. Then after we just find the area, find the difference, and end the program. Any questions, please? Hey, are you there, my dear friends? Are we there?
Yes, sir.
Let me check if we are still
Yes,
there.
sir.
Okay, we are still there. We are still there. Yes. Any questions or not? If there are no questions, then I want to ask you a simple question. Can I go ahead and ask you a simple question?
Yes, please, sir.
Okay. So you can see my whiteboard, right?
No, please.
Oh, really? Whiteboard?
Yes, please.
You can see.
Okay. So I want us to see if we can create a simple program that can find. Hello? Hey, stop writing. Hey, who's that? Mr. John Adam, stop writing on the whiteboard. Jonathan, stop. Hey, please stop. Oh, my friends, please stop. Okay, so we want to write a simple program that can, let's say, let's see, that can say or print our name. Okay, let's design a simple program in pseudocode that can print our name, that can take the user's name and print it onto the screen. Okay, so let's do our brainstorming. Okay, we'll do our brainstorming over here. Okay, so what is our input? What are our inputs? Okay, what is the processing? And then what is the output? Stop writing on the screen, Michael. Okay, so number one, what is our common input? Yes, we want to design a simple program in pseudocode that will take the user's name and print it to the screen. Yes. Who's helping us?
Name.
Yes.
The name.
To begin with the name.
What's the name? What's the name? So we just take the name like that?
Yeah.
No. Yes. What input do we need? Hello?
So we'll input name.
Oh, okay. You're talking. So let me just contribute one thing. So first and foremost, you need a variable for storing. Hey, someone who is Roland Boat Odro. Mr. Boating, stop what you are doing. Hello? Okay, thank you, Mr. Boating. So you need a variable, okay, you need a variable for the name, okay? Make sure that that variable can collect a name. We talked about what a string is, right? Hello?
Yes,
Last
sir.
time we talked about data types and we mentioned string, right?
Yes, sir.
Okay, so make sure that the variable or the container can take name. Okay, it is then that you now, so what's the processing that you do? You now what? Collect the name. Okay, so the guy said you should do a prompt. So enter your name, then you do what? An input. Okay, then you collect the name. Then what is your output? You want to print the user's name. Okay, so now let's write our program. So number one, we start our program. Number two, we create our variable. So we declare string name. Okay, so we declare remember, name is a variable. And when we do declare string name, what we're simply saying is that create a container called name. Are you okay? Are you with me?
Yes, sir.
Okay. Then number three, the gentleman said do a prompt. So we need to what?
Hello.
Yes, sir.
Say for the number two, can you also say declare name as strange?
Yes. Remember I said it's called pseudocode. So there's no right or wrong. Okay. So it's very correct. You can say declare. Yes, you can do that. Are you with me?
Yes, please.
Hello.
Hello, sir.
Okay, so can you hear me at all? Can you hear me?
Yes, sir.
We can hear you.
Okay, the gentleman is not responding again. That's why I'm asking. Okay.
David, sorry, what do they do?
Those who are writing on the whiteboard, stop doing that. Stop. Please stop. Okay. Okay. Then the next thing is that we want to prompt. So we can say maybe write. Then what do you want to write? You want to write enter your name. Then double quotes. Remember, when we put something in double quotes, it means it's a string. Okay. So number 4, we say input name. Notice that this name over here is the same as this one because that's the variable. So whatever you enter at the keyboard, we collect it and put it inside the container. So we have a container called name. So for example, if we enter Kwame, we collect Kwame and we put it inside the variable called name. Then number 5, after doing the input, the input, we go and do processing. Okay, so we go and do the process. So we go and do the output. So the output is what? Write your name is, then we concatenate it with the variable name. And then number 6, finally, we do end. Okay, so these steps describe very, very simple steps of how to print or create a variable called name, ask the user for the name, enter the name or input the name, and then write your name. So basically what the user will now see is that when sorry. So so what the user will now see is that when the user tries to print, or when the user runs this program, they will see your name is Kwame, because Kwame is what is inside this variable. Okay, remember this variable name contains Kwame because you entered Kwame. Okay, everybody understands now, right?
Yes, sir.
Okay, that's very good. Hey, Roland Boateng, stop writing on the thing. Oh, come on. Why are some of you so hard and difficult to talk to? Okay, so yeah, so any questions? This is what we'll normally be doing. So you write in pseudocode. This is called pseudocode. Oh, okay. You write in pseudocode. This is called pseudocode. Very, very simple to do. Okay, you can see it's very simple, very nice, very easy. Okay, let's do another example together. So for example, another example. Kofi Richmond, stop. Mr. Kofi, stop. So, for example, if we want to create a program, let me choose this one. If we want to create a program that will do simple interest, okay? Let's create a program, simple program that will do simple interest. So let's talk about the input, the processing, and then the output, okay? So number 1, what inputs? Oh, who are those writing on the screen? Hey, gentlemen, please stop. Okay. Thank you. So, for example, for our input for doing a simple interest program, Okay, so we are brainstorming over here. Okay, so we need what? Something for principal. We need a value for rate. We need a value for what? For time. And then we need another variable for what? For simple interest. Okay. Hey, would you people stop doing that? Okay. So we need an input for what? For principal, for rate, and for time. Then what processing do we need to do or carry out for this input? Okay, what's the processing we need to do? Yes, I will not do everything for you. Okay, so who are now asking, what processing do we need to do for this program? We want to calculate simple interest. We know that we need principal, we need time, we need rates. What processing do we do for this program? Yes.
So, sir,
Oh, are you with me?
Yeah, I thought you used the that's the interest formula.
Yes. So what's it? What's it? Yes.
PRT over 100.
Oh, you're not talking like a programmer. Okay. So simple
no.
interest is equal to P star R
Yeah,
star T over. Remember, we said that you can write P and then times R, okay? Because in programming, there's no
yes, sir.
times, right? It's not possible to do it in programming, okay? So you do the star instead, okay? So this is the processing you need to do, okay? Then the next thing, what's the output? What do you show as output?
But you sir, do you multiply them or you calculate them?
Oh, I don't understand what you mean. What do you mean by you multiply them or calculate them?
Is it when you've entered the distance, then you
By to multiply them and then divide them by 100. I'm asking for output. Output. What do you show as successful output?
Print solution. That's the total simple something or total amount or something.
uh,
Come on.
You display the SI.
You show the what?
SI.
Ghana. You
GSI.
show the simple interest. That thing is written over here. Oh, Chineke, Ghana.
Yes.
Okay, so that's what you show as output. Okay. So now let's go back to the program and then complete the program. So now that we have the understanding, this is the brainstorming, okay? We know that we need three things: principal, rate, and then time. And then we need to calculate what simple interest, which is equal to what? P times R times time over 100. And then we need to print out as output what? Simple interest. So I'm contributing line 1, which is start. Somebody should contribute the remaining. Yes, who's helping us? You raise your hand and you talk. Please don't talk without raising your hand, okay? Yes, who's helping us with the next line? Hello. I'll mention names. Roland Boating. Please answer the question. What is line 2? Thank you very much. Mr. Gilbert says you declare the variables. So what variables are we declaring? What are your variables you are declaring? So
The principal
okay.
time
And what will be the data type? Yes. what will be the data type of the variables?
Float.
Prince, if you don't stop, you answer the second question, okay? What will be the data type? Yes. Oh, no. You know that decimals, you know that rate is a decimal, right?
Yes.
So you cannot declare rate as integer, okay? So let's use float, okay?
Float, yeah, float, yeah.
So we'll declare rate, we'll declare principal, we'll declare time, okay? Then let's add the declare for the simple interest. Because we are doing over 100, we can also get a decimal, okay? So simple interest. Okay, so what's the next thing to do? Line 4. Next thing, who's answering the thing for us? Next thing to do. Boating Roland.
Sir.
Yes, answer the question. You are writing on my board. Stop. Samuel Ajin. Stop writing on the board. Hurry up. Yes, what's the next thing we need to do? After declaring the variables, what is the next thing we have to do? Based on how we did the brainstorming.
I thought you input that's the values.
Yeah, so tell me, it's not about you thought. So tell me, what will we do? Okay, so you write the prompt, Michael into. Thank you very much, Michael. So you write the prompt. Oh, Solomon, give me back my board. Solomon Yerenchi.
Yes, sir.
Give me back my board. You've taken over my board.
Oh.
Oh.
Hey, you stop doing that.
Sir, has it come?
David Asari, stop presenting. Hey. The course rep, can the course rep turn everybody's thing off so we can David, who's David Asari? You have taken over the board.
David Asari.
David Asari, you have taken over my board. Hey, what is all of this?
So they don't know how to go about it.
Okay, I think he's giving it back. Okay. So the gentleman was saying we should write a prompt, okay? So you write enter the enter the rate, okay? And then number 5, you will input the rate variable. Then number 6, you will write the prompt for what? Enter the principal. Then Then number 7, you will input the principal, okay? Then number 8, the last but not the least, you will do the prompt for enter the I think we're left with time, So enter the time. Then number 9, you will do the prompt for input time. Okay. So now you've done all the inputs. Okay. So now that we are done with the inputs, what's the next thing to do according to the plan? After the input, what do we do next?
You output the.
No. After
Yeah,
input, what do we do next?
You
You process.
You do what? Hello? Oh, we just done the input. So what do we do from input? Where do we go? Can't you see something below the input before the output? Hello?
You process.
You process. It.
Yes. So number 10. Hey, who are those people drawing boxes around? Oh, Chineke. Okay. So number 10, you will do the you do simple. So you do simple interest. Is equal to, into brackets, principal star rate star time, close bracket, all divided by 100. Okay. Then number 11, what do you do from there? What do you go next?
Output.
You output.
Yeah, so we are going to output the simple interest. So output means you are going to write to the screen the simple interest is, then you can concatenate it with what? Simple interest. Okay. So congratulations. You are almost at the end. Now you are at the end. Okay, so we have this simple program. And what this program does is that this program creates 3 variables. Okay. This program creates 3 variables called rate, principal, and time, and then creates a 4th variable called simple interest. Then it creates some inputs over here for all the 3 variables to collect the 3 variables. So we do a prompt, we collect, we do a prompt, we collect, we do a prompt, we collect. So you have the inputs. Hey, say why, Erica, you joined them. Okay. Then you do the simple interest is equal to principal times time times rate divided by 100. I told you that in programming, we write in a straight line. You cannot do this in programming. It's not possible to do this in programming. So you write in a straight line. Okay. Then we output the statement, the simple interest is, then quote plus simple interest. So this one will cause the number to follow the sentence. And then you end the program. Because there's a start, there's always an end. Is it understood by everybody?
Yes, sir.
Okay. Thank you very much. So let's quickly go to the other part of our the presentation, and then we'll take it from there. Okay.
Thank you so much.
Now, pseudocode is not the only one, or not the only tool that can be used for showing. Oh, there's a hand up.
Yes,
Please
sir.
ask the question quickly. Okay, our time is fast spent.
Oh, okay. I was wondering if you could give us other assignments so we try and hands-on.
Oh, I'll give you a very big assignment. Hello.
Okay, sir.
Can you hear me?
Yes, please,
There'll be a very big assignment on the LMS very soon. Okay, so be expecting it.
Okay, thank you very much.
Okay. So, what was that? So, pseudocode is not the only tool you can also use to express an algorithm. Another tool you can use to express an algorithm is what we call flowchart. Okay, flowchart is also a very simple tool you can use to express algorithms. In fact, flowchart is more, flowchart is more graphical. Okay, what it means is that it has a diagram. And so you read, instead of reading the text, you read the diagrams. Okay, and it also describes the step-by-step design. It will give you a visual map of how the program looks like. Okay. The purpose of flowchart is to visualize the design. Okay. Now, some of the uses include what? Representing decision making, mapping the flow of control, outlining the program, depicting the authentication logic, illustrating the data processing, and visualizing object-oriented relationships. These are all uses of flowchart. Now, let's go to flowchart proper, okay? Now, flowchart has some shapes that we use to communicate because it's a visual programming tool, okay? So, number one, if you want to represent the start and the end in programming, we call it the terminator, okay? So we use something like the oval, okay? Or we can use a rectangle that has a rounded edge, okay? So then you write the start or you write the end in the oval or the rectangle. Are we okay? Then you can also use the arrows, the lines and the arrows to show the flow of control. Remember, the name says flow chart. So you must always put an arrow at the end of the line. It's important. Okay. Then another thing too is that flow chart, we use the rectangle to indicate processing. If we are doing calculation, if we are creating a variable, if we are doing any of those things, we call it processing. Okay, so we use a rectangle. Okay, then we use what we call a parallelogram, a slanted rectangle to indicate input and output. Okay, so when you are doing write or input or print or show or display, those things, you use the slanted rectangle. Okay, now you can also use the conditional, which is what? The diamond. Okay, we call this the kite or the diamond. Okay, we use it to represent what? Conditional statements like if statements and even loops like while loop or do while loop. Okay, so please remember that we use the diamond for those things. Okay, now you have those shapes over here. So this one is for the terminator, this is for the flow of control, this is for the input output, this is for processing, this is for conditional statements. Okay, let's look at an example. So the first example is very, very, very simple, very easy. On the right, I have the pseudocode, and on the left, I have the flow chart. Okay, sorry, on my left, I have the pseudocode, and then on my right, I have the flow chart. So let's look at the pseudocode first, since we now understand pseudocode, right? So in this program, we start on line 1. Then we create 2 variables, one variable called my number, second variable called my answer. Then we collect the value from the user. So let's assume that the user enters the number 4. So the number 4 will be put inside the container called my number. Okay, so please remember that. Then we do a processing. What processing do? We do my number, which is 4 times 2. And so the answer 8 will be put inside my answer. So now wherever I see my answer, I see what? The number 8. And so when we do write my answer, you rather see write the number 8. Okay, now we end the program. So over here, let's look at the relationship between the pseudocode and the flowchart. Notice that every line of the pseudocode has a corresponding flowchart shape. So the start will run all the way to here. Okay, so that shape is what? Representing start. This shape represents start. Then declare is a process. So this shape is rectangle. Then input is a parallelogram. So this shape is a parallelogram. Then set is a process. So this shape is a rectangle. Then write is a parallelogram. So this shape is a parallelogram. Okay. Then the last but not the least is the end. So this shape is the end. Okay. Are we okay?
Yes, sir.
Okay. I hope there's no confusion. Remember the shapes. You just need to remember the shapes. Okay. So for start, we will use the oval. Then we use the arrows for flow. We use the parallelogram for input and output. We use the processing or the rectangle for processing, and then the kite for those things. So look at the shapes and look at the words that indicate the shapes. Do you see the relationship?
Yes, sir.
Okay, that's very good. Okay, second example. So here too, I decided to use another word, begin, to indicate the start of the program. Declare is a rectangle process. Write, input, write, input. These are all the same shape. So what I try to do is to represent them all with one shape and write the various instructions on the shape together. Okay, so if you have several write input in the same or following each other, you can just draw one big shape and write them all on them. Then set is a process, so rectangle. Then write is a parallelogram. Then end is a process. Sorry, end is a terminator. So you end with an oval. Any questions? This program, we have seen it before. Okay, this program is the program we did where we added two numbers. Any questions? Can you hear me well?
Yes, sir, we can hear you.
And you're okay with it?
Yes, sir.
Okay.
Can you go back? Please go over it again, sir.
Okay, so I did say that, if you remember from here, I did say that in flowchart, we simply use the shapes, the correct shapes, to represent the particular thing. Okay, so for example, if we see start or you see end, you use this shape. If you want to indicate where the flow of control is, you use the line with the arrow. If you want to do input or output, right? For example, you want to do write or input, you use the parallelogram. If you see the word declare, okay, or the word set, okay, or the word calculate, any of those words indicate what? A process. So you do this one. Then if you see an if, or you see a while, or you see any of those other words indicating decision, you use a kite. Okay, so all we have to do is to read the line and indicate it with the correct shape. That's all we are doing in pseudocode. So sorry, in flowchart. So look at this very carefully. If you look at this, you notice that, oh, sorry. So if you look at this, you notice that here, sorry, eh? Okay, so if you look at this, you notice that here we are starting. So start is a terminator, okay? We are declaring, so it's a process. We are inputting, so it's a parallelogram. We are doing calculation, so it's a process. We are doing what? Output, so it's also a parallelogram. And then we are doing input, so sorry, we are doing an end, so it's a terminator. Okay, same thing applying over here. Begin is a terminator, so we are starting. Then declare, so we are processing. Then write, input, write, input. You can draw them one by one, or if they are all together like this, you can put them all on one shape. So you notice that the shape is the same for all of them. Okay. Then set is a calculation, so we are doing process. Then write is an output, so we are doing parallelogram. And then end is a terminator. So all the pseudocode you've written, you can actually draw the flow chart. Okay. Then another one over here, we are finding the area of a rectangle. So we see the terminator declares a process. We can see the right. All of this is the same shape because you see right input. It's all parallelogram. Then set is a calculation, so you see process. Then write is an output, so you see the parallelogram. Then end is a terminator. So do you see that every line of your pseudocode has a corresponding relationship over here?
Yes, sir.
Okay. All you have to do is to remember that the shapes are just about 4 or 5. Okay, it's very, very simple. About 4 or 5 shapes. It's not difficult to remember what each shape does. Okay. So here the terminator for starting, declare the variables is a process, and then write and input are all parallelograms. You see, some students are known to draw a rectangle around this, some like this, okay? And then they'll leave it like this for me to decide on whether it's a rectangle or a parallelogram. Okay, please don't do that, okay? So if it's a parallelogram, write a parallelogram, draw it well so we can see the slanted edges, okay? It's very important. Are you with me?
Yes, sir.
Yes.
Okay. Then here, last but not the least, we have another example over here. Here we are finding the area and the circumference. Remember, we've already written this program before. This program, we've already written it in the pseudocode. We are just converting it into flowchart. So the start is a terminator. Declare is what? A process. Write is write input. Yes, they are parallelograms. Thank you very much. And then set. These are all what?
Processing.
Process. Thank you very much. So 1, 2, and 3. Then write is all what? Parallelogram. Then end is an oval or a rounded rectangle.
Okay.
Very, very simple.
Sir, please.
Yes.
Sir, please, why didn't you write the processing in one rectangle?
Oh, I also wanted to show you that you can also write it individually, or it's not by force. I just want you to see different ways of doing the same thing. Okay.
Okay, sir.
Thank you. Yes. Any other question? Okay. So let me go back to our whiteboard. Please don't write on the whiteboard. Okay. Okay. So I want us to okay. So now let's look at the whiteboard, the program we wrote. Let's look at the program we wrote, and then we'll draw the flow chart for the program. Hey, I said don't write on the whiteboard. What is John Adam doing? Hey, people, better stop that, okay? So the start, what do we represent start? Let's start with this program, the first one over here, number 1 over here. So what do we use for start?
Terminator.
Yes, so the oval, terminator, okay? So you write start in it. Hey, people should stop doing that, okay? Why are you writing on the board? Then what do we use for declare?
A rectangle.
Rectangle. Thank you very much. So you should write or draw the rectangle. Okay, my rectangle is not very good. Okay, not looking nice. So you should draw the rectangle. And then you should write what is on this one. So declare string name. Okay. Then you should put an arrow between the start and the declare. Okay. Then where do you go for next? We go to write and then input and then write. So what do you think we should do? Let's do it one by one. Okay. So the first write, what shape is it?
A parallelogram.
Parallelogram. Thank you very much. So you slant the rectangle small, okay, before you join it together. Okay. Then you write, enter your name. So enter your name. Then second one, input. What shape?
Rectangle.
Hey,
A parallelogram.
I'll come for your I'll come for your phone, okay? So you just write input the variable name. Then last but not the least, this one, line 5, the right. What shape is it?
A parallelogram.
Yes, sir. Thank you very much. A parallelogram as well, okay? So you write your name is plus name, okay? Okay. Then the last one, end. What shape is it?
Terminator.
Yes, an oval, okay? So end, okay? So notice that the program is very simple. Once you can master flow pseudocode development, you can look at every line of your pseudocode and then draw the flow chart. Okay, very easy. Notice that over here too, if you write or if you draw the wrong shape, because the answer is about shapes, if you draw the wrong shapes, you are wrong. Okay, you have to draw the correct shape. If it's a rectangle and you go and draw a parallelogram, you are wrong. Are you with me?
Yes, sir.
Yes.
Okay. So this is where we call it a day. And I want to ask if there's any question. If not, I would advise you to go to the LMS, go and do the small quiz I have after here, and then get prepared for the assignment I'm going to give you. You will work in groups of 2. Your class is very small. In fact, you can even do groups of 1, but because the other group is also doing groups of 2, let's just do groups of 2, okay? So that at least 2 people is enough. No more than 2 people in a group, okay? Okay. So any question? If there's any hand up, I'll answer the questions and then we will call it a day. Mr. Johnson.
Yeah, okay, sir. So if we are working in groups of 2, does it mean you'll be presenting?
Oh, it's an assignment. So you go and work it and then write it, and then you bring it during the face-to-face.
Oh, okay, sir. Okay, sure.
Yes, you not upload it online. You bring it during the face-to-face.
Okay, sure.
Yeah. Yes. Any other question? Okay. No other question? Mr. Johnson again? Mr. Holy?
Hello.
Okay, so please, we do have groups already, or we shouldn't use that.
Oh, you can use that. I'm not going to create the groups for you. In fact, I allow you to use the groups, but I said group of 2 people. So it cannot be more than 2. If you already have groups, that's fine. But for my assignment, you will present it in groups of 2 people each.
Well
No
noted,
more
sir.
than 2.
Very well noted, sir.
Okay, thank you. Any other question, please?
Yeah, sir. So please, what
Sir,
happens
please.
if you are not around?
What do you mean by you are not around? I don't understand.
Please, I'm currently out of the country, so I don't know how it's going to be done. If I'm to bear with someone, please.
Oh, but we are all working from online, okay? So you just
Okay.
have to find a partner within your class group who is also going to be around and can present the assignment on your both. I don't think if I say groups of 2 people, the 2 people will hold the pen and then write together all day. I don't think they can do that. So one person will still hold the pen and write the pen.
Okay, sir. Thank you.
Sir, please, in flowchart, is it necessary to declare variables in flowchart, or you can skip that?
Oh, it's program design. You need to, every program, if you are going to use variables, you need to create the variables by declaring them. So you cannot skip the variable creation. You have to declare the variables. It's important.
Okay.
You can see that in my program, right? So you can see that over here, right? I always do variable declaration, even the first thing, that's the first thing I do before I even go to the input and output. Okay? So variable declaration is very important. Do not skip variable declaration.
All right, thank you.
You're welcome. Okay, I think in the absence of any questions, we will call it a day, and then we'll see you guys. I think, we'll see you guys at the next meeting. Are we okay?
Yes, please, sir.
Okay, thank you very much. Thank you very much.
Thank you, too.
Bra solo.
Yeah.
No, yeah, fanboy things. One, sir. Auntie Erica, today I not hear from you.
Massa. The woman you know hear from her. You see her before.
Boss, I beg.